right from the get-go here, I want us to make sure that we are skill-focused and exam-focused. Yes, we are doing Hot Topic 10. Yes, it's about recovery and EPOC and all that stuff. But the first thing that screams out to me on this screen is that word there. That is what that means to us is we need to break things down and explain each of those things. That's my word for that. That's my description of that. So we're going to analyse the effects of EPOC, the excess post-exercise oxygen consumption, on an all-round gymnast between apparatus during a competition. So it's a really hard question, I've got to say. And the topic itself is not hard, but this is an all-round gymnast, so a gymnast that does all of the events. But what EPOC does between the apparatus. So let's have a look. Firstly, a classic word when we're analysing. We're going to say the first thing I'm going to explain is all gymnastics apparatus are predominantly anaerobic. So our anaerobic systems, those being obviously our PC and our glycolytic, they're going to be predominant in all of the apparatus, with many being ATP PC. Therefore, the anaerobic systems need to be recovered between the apparatus. What is the plural of apparatus? And this is done aerobically. So just one thing I want to make clear here, guys. When we recover, it's an aerobic process. Because breaks are quite long, and definitely longer than 2 to 3 minutes, which of course is how long the PC system takes to recover 100%. PC stores will be, let's say, fully resynthesized. So each event, each apparatus that our athlete does, their PC system will be fully resynthesized in the alactic component of EPOC. There is also sufficient time for the removal, now going into like that slow component, removal of lactic acid, and the resaturation of myoglobin, and resaturation of myoglobin in the lactacid stage. So that's obviously the slow stage, the slow component. Now, we just want to finish this off. One exception. So there's something where actually this might not be the case. One exception to this might be the 2 volts. You know, in gymnastics, when we're doing all-round gymnastics, is when they're on the vaulting apparatus, they do the 2 volts back to back. The 2 volts that they do, I'll just put that like, I'll just miss that little bit out. The break between is very short. So lactic acid, so I'll just put LA, lactic acid, may well be present. For Volt 2. Or for the second Volt. I'll put for Volt 2 or second Volt. You can put either of those for Volt 2. Now, guys, that is a lovely answer because I want to make a couple of points here. First of all, I have clearly applied to this specific situation of all-round gymnastics. Secondly, let's have a little look at what your examiner might do. Now, your examiners are examining online. I'm effectively examining on paper, even though it's a screen here, but I'm writing with a pen. So just what this will be is this here will be picked up, and all of them predominantly anaerobic will get you a mark. We've got here, the breaks are long and definitely longer than 2 to 3 minutes. Therefore, PC will be fully resynthesized. This is going to get us our mark. I highlight that, I tick it, I get my 1. There is also sufficient time for the removal of lactic acid and the removal of myoglobin in the lactacid stage, more of which in a second. There we go. And at that point, folks, we have got our max. Now, there is credit below. But because that credit is all, because we've already reached our max, this effectively, either your examiner, what sometimes they do is they'll just move on. But sometimes what you see on your paper is that this says seen. So the examiner has seen that. So sometimes you get that sort of reference because they will do that. Now, what I want to do here, folks, is I want us to depict an oxygen consumption curve. So I want you to go with me a little bit. And first of all, recognize our axes. That's the first thing we need to do. We need to recognize that what we've got here is we've got time in minutes progressing on the x-axis. We've got oxygen consumption progressing. Should have that really. Progressing on the y-axis. Just bear with me. Let's put my little arrow on there. Doesn't really matter, but let's put that in there. Now, let's see if we can start to sketch out this curve. This dotted line here is the start of exercise, and this here is the end of exercise. Let's assume this person's doing like a 20-minute training run or something. So maybe we've got 0, 10 minutes, 20 minutes, 30 minutes. It's not quite to scale, but you get the point, 40 minutes, something like that, okay? So let's see what we get. First of all, our oxygen consumption would be at some kind of resting level. So let's decide this is our resting level. That was meant to be a different color. It was meant to be orange. A resting level. And what's going to happen here is prior to the start of exercise, our oxygen consumption is going to go up. Why is that happening? Well, we know that's because of that sort of anticipatory rise, okay? Now, what's going to happen here is that curve is going to continue to rise until it levels off, let's say at this level here, and we are then going to get steady state exercise until the end of exercise here. Okay, now I want to make a point clear to you here, folks. Here, this area here, that there is oxygen deficit. In other words, this is a volume of oxygen that would have been used if it were available. In this time period, sort of from here to about here, in this time period, your aerobic system, such as your vascular system, your cardiac system, your respiratory system, are trying to gear up to get more oxygenated blood to the working muscle. So here, this is a bunch of oxygen delivery above the curve, therefore it didn't happen. So this deficit at some point is going to have to be paid. Now, let's move forward. What happens at the end of exercise, what doesn't happen is that oxygen consumption returns to rest. If there was no deficit, that's what would happen. Rather, we get a steep fall in oxygen consumption, like this. And then what I think you guys already know, we get, let me choose a red color, let's say, we get a leveling off, like this. Now, I've not drawn it particularly well, but that's what we'd expect to see. And of course, what we want to recognize in our illustrations is that this period of time here, sorry, let me be clearer. This quantity of oxygen here below the curve, this is EPOC. Okay, this is EPOC. And that EPOC is there to pay off that oxygen deficit. Now, I'm going to get into more specifics in a second. But you might be thinking, well, hang on, James, let's calm it here, son. EPOC is bigger than oxygen deficit. Yes, it is. And that is not just bad drawing on my part, folks. That is deliberate. Because the thing you've got to remember is that this value here, however much oxygen that is, this is a bunch of stuff that didn't happen. It's a deficit. Here, this did happen, and therefore it's mechanical and has to be powered. So in order to do this stuff, to actually do this, we have got a series of more powerful heart contractions, more heart contractions. We've got to be powering the respiratory muscles. All of those things require oxygen, and therefore that's what this looks like. The other thing, folks, we have to remind ourselves that there is, and it's not literal, by the way, but there is a dividing line here between what we're going to call the fast component in the green section. Let me just sort of sketch it in here. The fast component, I should have written that in green really. The fast component of EPOC. There we go. And the slow component of EPOC. And down here we've got the slow component. And I'm going to write out for you what each one does. But we have got obviously the slow component of EPOC down here, and that is the key point I want to make. This process post-exercise, of course, EPOC is the quantity of oxygen utilized post-exercise over and above that which would have been used at rest. That is to pay off that deficit that's been built up, and of course this work here has had to be done anaerobically, just as this work now to recover it has to be done aerobically because it's a recovery system. So what happens in this fast and slow component? Well, let's have a look at it, folks. So first of all, that's interesting. First of all, let me just put my black pen back into place here. First of all, this is called the alactacid component. We get the resynthesis, is the fast component, that green bit. This is the resynthesis of phosphocreatine. It's a resynthesis of ATP. It's the resaturation of myoglobin. Okay, myoglobin. Active cool downs speed up the process. So if we do an active cool down, it speeds up. We get 50% recovery of phosphocreatine in 30 seconds. Now, if I'd drawn that graph well enough above, you should literally see after 30 seconds, I would get 50% of this proportion done. Now, I don't think I drew it well enough to show that, but theoretically that was, so it's a very, very kind of steep fall. We get 100% recovery in 2 to 3 minutes. Okay, different things tell you different things. And it takes approximately 2 to 4 litres of oxygen in this process, okay? Now, if we go over to here, folks, what have we got in our slow component? That red bit up above, you know, that red section there. What have we got? We've got our lactacid component of EPOC. We get the removal of lactic acid. Lactate broadly is processed for energy in the main, and it's converted back to pyruvate. I'm not going to get into this, but it's oxidized into CO2 and water. By the way, some of it is passed out as it's actually converted to proteins. All kinds of stuff are going on here. This is literally breathed out, and I don't want to get into buffering and all that kind of stuff here, but nevertheless, we've got transport in the blood to the liver to be converted to blood glucose and glycogen. This is a Cori cycle. A-level biology, you know about this. We get a small amount converted to protein. This is what happens to lactic acid, but this can take up to 1 hour. Okay, so slow components can take a long time, but if I just tell you that 5 minutes is also enough to get most of it done, and it takes between 6 to 8 litres of oxygen to perform those functions. So there we go. There's our recovery. And there we go. What a contrast for topic 9. We're going to jump over to section C. Define the terms discrimination and prejudice. It's an interesting question, this, because I wonder how many students can just sort of automatically pull these definitions from their minds, okay? And that's an interesting sort of reflection for you. Discrimination is what? It is treatment of people, but it's not nice treatment, it's unfair treatment. So there's our key term. It's unfair treatment. Discrimination is unfair treatment. Discrimination is unfair treatment of who? It's of a minority group. Okay, now I'm not going to get into what the alternative is, a hegemonic group, but there's certain sort of assumptions here. Therefore, what is prejudice? Prejudice is forming an unfavourable opinion, an unfavourable opinion. But we do this, I don't know if I want to group myself into this, form an unfavourable opinion about someone or group of people based on a predisposed characteristic. So what would be a predisposed characteristic? Someone's sex, for example. What about someone's age? What about someone's skin tone? What about someone's ethnicity? These are all predisposed characteristics. What about, let's say, maternity and paternity, of having children? There's all kind. They're actually called protected characteristics in the UK, and we're not going to go as far as that. But these are all predisposed characteristics. This is what people are by definition. Okay, so if someone forms an unfavourable opinion on me, for example, because I've got my head shaved, that's just that's a prejudice, isn't it? You know, I mean, to be fair, I do look ridiculous, but that's not the point. And what's your examiner going to do? They're going to say unfair treatment of a minority group, key terms language mark. They're going to say forming an unfavourable opinion from a predisposed characteristic. Link those two things together. Tick. There's our max. Fantastic. Now let's just remind ourselves of a couple of other key terms. Equal opportunities, the right to access the same things. Okay, the right to access the same opportunity. I am happy to say that in the UK today, opportunity, I'm not talking about provision and esteem, I'm talking about opportunity, at least theoretically, is even. Now, you might not agree with that, but I'm saying that is arguable. You can certainly try and hold that position. I'm not saying it is achieved perfectly, but nevertheless. Discrimination is, and I'm just going to repeat that because I think what did James just say? How dare you? No, hang on a second. I'm talking about opportunity specifically. I'm not talking about provision. I'm not talking about esteem. Esteem is how identified people feel in certain situations, whether they feel part of something, welcome in something, attracted to something. But in terms of opportunity, for example, there is no opportunity at university that isn't available to all members of society. Now, there might be provision that makes it less likely for some, but opportunity itself is equal. Oh, that's a big statement. Discrimination, the unfair treatment of a person or minority group. So, to make a distinction and act on the prejudice. So, overt and covert discrimination. Sometimes people, you don't see that and hear overt discrimination. People have kind of learned not to say certain things, but people will discriminate kind of privately, quietly, without acknowledging it. Overt is visible and obvious. Covert is hidden and less obvious. Let me give you an example. Let's find a rugby coach. There's a rugby coach, and they coach at a rugby club, and there at this rugby club there is male and female sections, and they're only interested in coaching the males. That would be discriminatory, right? That would be like, okay, my behaviour in this way. Stereotyping. A standardized image, a really nice word I would say is a generalization. It allows people to categorize other people and then treat them accordingly. If you stereotype, you're assuming someone is a certain way because of some kind of false generalization about that group of people. A prejudice is forming an unfavorable opinion, and it's often based on a lack of facts. In fact, I might challenge that word to say always. Maybe. Okay, here's a question. It's a fascinating one. The table shows viewing figures for the Paris Olympics and Paralympics. Using your knowledge of commercialization, analyze the coverage of disability sports in the media. Refer to the data from the table in your answer. So let's just get the big picture here. Basically, pretty much twice as many people watched the Olympics on BBC than watched the Paralympics on Channel 4. Now, there's a couple of things you could draw from that. People don't watch Channel 4. That's one of them. Well, 90 million people did. But there's certainly a disparity. Viewers as a percent, so 59% of the UK population watched the Olympics, 30% watched the Paralympics. There's a difference, right? So how would we put that into our answer? Well, what we want to do here is do a little highlighting job, folks, okay? And we've started, the answer's there for you. And guys, by the way, before we start this, can I just stress, you should learn this answer. And if you don't like me for saying it, tough. That is what you should do. That answer is beautiful. It's the standard that gets us full marks, in my opinion. And therefore, you should sort of look to learn it and be able to reproduce it or something similar to it. Let's have a look what we've got here. We are going to carry on the highlighting once it's been started. Notice that AO1, knowledge and understanding, is red. Application is AO2 and is in yellow, and that sort of evaluative or analytical point is in green. And what have we got here? We've got a analyze question, so we're going to break it down. So let's have a look at paragraph 1. Commercialization is treating sport as a commodity with the main aim of making profit. This is known as golden triangle, which involves the media, sponsors, and elite sport. The media companies primarily focus on broadcasting elite sport, which can include coverage on local and national radio stations, TV and streaming online or on mobile devices through apps. Excuse me. The Olympic and Paralympic Games are ring-fenced, which means that they are shown on free-to-air TV due to the worldwide interest and global nature of these sporting events. So first of all, what I want to stress here is clearly what's happening here is this is AO1, isn't it? I've got a block of AO1 content. In fact, what's happened here is that the student has come along and said, right, I'm going to define what commercialization is. I'm going to define basically what the Olympics Games are and how they're televised and those kinds of things. Now, what's in block 2? Paragraph 2, we have got here the data. Sorry, I meant to change my colour. Trying to get the same orange, it's not working for me. The data in the table above highlights the significant differences between Olympic and Paralympic viewing figures. For example, 36.1 million viewers watched the Olympic Games on BBC Sport, whereas 18.5 watched the Paralympic Games on 4. This is just over half the number of viewers of the Paralympic Games. The lower figures for the Paralympic could be due to less coverage of disability sport throughout the year. So, guys, I am now analysing here. So notice that I've taken data from the table, and now what I'm doing is I'm making analytical points about that data. Okay, so I've got a little bit of green into there, therefore generating a lower interest when compared to Olympic sports that may feature more prominently in the media. Okay, athletes taking part in the Olympics may also have a higher media profile as a result of more coverage. We've also got an analytical point here. We have got the fact that Olympic athletes have higher profiles and therefore attract more TV audience. So the audience may be less aware of Paralympic events. Okay, so again, another analytical point, which could explain the lower viewing figures in comparison. So what we've said here, there's basically an application here. We've basically looked at the data showing that twice as many people watch the Olympics as the Paralympics. Here's some reasons why. Now, what happens in the next paragraph? It says viewing figures for both the Olympics and Paralympics are comparatively high. So it's saying, look, yes, only 19 million people are watching the Paralympics compared to whatever it was, 37 million, but still a lot of people. So why? Let's see if we can state why that is. Due to global interest. So we've got a fact state from the data. That's the application. The Paralympics also takes place shortly after Olympics. That could be a reason why they're both high, which may increase awareness and coverage through the media. Now, I want to make a genuine. I'll ask this question. Treat it. Well, it is rhetorical, so I've got no one to talk back to me. But compared to, let's say, Paralympic World Championships, how many people watch the Paralympics? It's a lot, isn't it? And is that because it touches up with that Olympics and sits tight? It's identified together, and I think there's some truth to that, isn't there? So therefore, that's an interesting point. For example, the Olympics TV coverage will feature previews of the upcoming Paralympics. So there again, so we've got the cross-pollination of one games to the other. And this will generate a high level of interest, which could lead to the comparatively high viewing figures. Having both events take place at the same time could have a positive effect. So guys, this is even more analysis where this writer, it's me, is saying that one way you could do this is not have them separate at all. Actually, have the Olympics and the Paralympics happening simultaneously. Admin nightmare, I'm sure, but could be done. However, the saturation of sport via the media, it could lead to fewer people watching the Paralympics. Now, is it a bad idea? Because at the moment, the Paralympics is close to the Olympics, but it's got its own space. If we mix it in with the Olympics, does it kind of get lost in the white noise, for want of a better phrase? Olympics, if they were to broadcast at the same time, I think the Paralympics should take place as a separate event. So this is our opinion. I think that this should take place as a separate event, which could further highlight the Paralympic sport and boost the profile of athletes as role models or spectators. Additionally, increased media coverage of the Paralympics could lead to increased viewing figures. Guys, the point I want to do is just show you that answer back to you. Look what we've got. We've got a block of red, which is fact. We've got 2 occasions where application. And then the rest of it is focus on the AO3. Focus on the commentary. Focus on the analysis. And that's a really interesting question. Now, again, I just repeat, you guys, you need to learn the answer. You need to be prepared to write something of that standard. We've got 3 ways to avoid a learning plateau. And this is where, despite ongoing trials or practices, improvement does not occur. So how can we do this? First of all, we can set individual goals. That really helps us to avoid a learning plateau. Moreover, we can coach to the highest of standards. And finally, we can correct errors in individual subroutines. Now, I chose those answers because in my experience, those are the bunch of answers that students will not write. So the fact that the key word there was individual, can you imagine how many students would write down set goals or use smarter targets? No, individual goals. Coach to the highest of standards, basically have the best coach possible. And thirdly, correct errors in what? Individual subroutines. Okay, and that's how we make sure we pick up our marks. The little details like that. Stages of learning, folks. I'm not going to go too detailed here. You've got all of the descriptions. Perhaps we'll refer back to them in a second. But one of the things I wanted to mention to you is obviously we've got this idea that people progress from the cognitive to the associative to the autonomous. There is an argument that de-learning can happen to some degree, at least in practice scenarios. Now, I just say that because, of course, you will experience in your own sort of participation in sport and physical activity that you can make the return journey. But the point we want to make here is that, sort of, it effectively takes longer to unlearn than to learn, if I can put it that way, which is a good thing, isn't it? But it's theoretically possible. But those are our characteristics. And guys, look, you're going to need to learn those terms and those descriptors and get them into your answers. What we are going to have a look at here, folks, is we're going to have a look at the concept of a learning plateau. And look, what we think is you've got a couple of questions you could get. What are the causes of a learning plateau? What are the solutions or shortening or preventing a learning plateau, like not progressing? And finally, folks, could you get an analyze question which actually asks you to do both of these? So causes of a learning plateau: performer not physically capable. That would make sense. You can't give a full size javelin to a 6-year-old and say lob that, mate. It's not gonna. It's gonna be a learning plateau in there. Task too difficult. Similar. Goals not achievable, realistic. Performer lacks the skill ability. Reached full potential. They're not going to go any further. They're not strong enough, fit enough, etc. Mental model of the skill is not fully formed, so that they don't have the schema breadth to actually improve it. Boredom, tedium, and lack of motivation. They don't want to achieve it. Poor quality coaching or teaching means they can't get over that point. So these are causes, guys. And imagine again that you've got an 8 mark. Analyze the role of learning plateaus in learning a skill. And how would you prevent or shorten or solve it? You introduce difficult tasks after mastering easy tasks. So it's easier tasks first, master them, move on. That's the master. In fact, let me put that in. That's what's called the mastery model. So it's a nice term for you to use. Set achievable goals. You don't want things that are way over target, set individual rather than team goals, improve fitness, use drive reduction. Now, we don't teach drive reduction theory on this course, okay, but drive reduction theory basically says that if you set someone a goal and that goal remains the same goal over a long period of time, that once the goal is achieved, there's no drive anymore. You've got to continually reset goals. So the idea of drive reduction theory is to reset goals. That's all it means. Ensure coaching is high quality. And by the way, some of this is always not on the spec, James. That may well, and this certainly will be, in the mark scheme. So let's be clear. Ensure coaching is high quality, of course. Use demonstrations to provide mental model. Fantastic. Especially for cognitive learners, right? Use whole, part, whole methods. You know, if you think about whole, part, whole, the part bit is for error correction. That's its role. So the reason we'd use whole, part, whole is literally to correct errors. And correct errors in subroutines, obviously, from the point above. There we go. There's your analyze potential question right there.